Well, hey friends, today we're going to be talking about troubleshooting PLC controlled machines. And specifically, we're going to talk about one, why it's so hard to make videos on troubleshooting PLC controlled machines, why you can't find good machines to teach troubleshooting, why we shouldn't mainly, or why we may not should trust our HMIs, how we should react when it's a mechanical problem, why operators are so invaluable when troubleshooting machines, and finally, what are the repeatable steps to troubleshoot most problems? And notice I said repeatable, not the fastest, because if we can come up with a repeatable method, we can gain speed. But we put out a riddle yesterday asking, okay, how would you troubleshoot machines? And the answers were honestly, the answers were not surprising. I know every riddle I have highlighted someone who like gave the great answer, and there were no wrong answers. I made sure I was clear on that. But really, two people came really close to what I thought was a good answer. Well, actually, two of you nailed it right on the head, but you've been to my class, so you don't count. I'm very proud of you for remembering how to troubleshoot machines, but yes, you that was a little bit of cheating. Now we have a different view for this because yeah, we are going to be talking about this machine trainer. In fact, if you haven't seen my class, I'll zoom out a little bit. Here's actually our classroom where we teach about troubleshooting. And this machine right here is the main machine that we use to troubleshoot. And so question number one that I get from a lot of you is, can you zoom into the classroom? And my answer is always no. And even last week, someone's like, no, I'll pay full price. I just can't, my company won't approve my travel. And I'm like, no, it doesn't work that way because, gosh, and then you never prep right. Actually, wait, yeah, this one, I'm going to drive my screen over a little bit. And if you look here at this trainer, if I can figure out where to point, there's no wires on it. And the reason there's no wires on it is you have to actually wire these PLCs up and you have to find out, oh, it didn't work. In fact, I don't think I've ever had anyone wiring work right the first time. So literally you've got to open up the manuals, you got to be able to figure out the manuals, you got to figure out, how to wire it. And then when it doesn't work, I'm just like, oh, well, why doesn't it work? And everybody's like, well, I don't know. And I'm like, well, why did you put the positive wire there? And the answer always is, well, that's what we always do. I'm like, okay, but why do we do that? And so it's really difficult for you to zoom into something and see that. And you get your wire hooked up, and 15 minutes later, because you didn't get it on the terminal screw good, all of a sudden it falls out. And you're like, well, it worked a little bit ago. Now it's not working. I'm like, oh, well, why is that? And you don't realize it, but you're gaining a lot of troubleshooting skills in that little bit of time. So that's why it's really hard to teach troubleshooting online. Even this video, I'm going to give you some really good fundamentals to follow. But if you don't like practice, 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 and practice, then really they're not going to sink in at all. But also, really, this is why I tell you all the time, get it, use the simulators to figure out whether you're really interested in learning this, but get yourself some hardware as soon as you can, because too many of y'all are stuck in the software part of it. And also when you go to hook up a wire out in the field, you get your first, real job or project, you can't do it. So you need practice on those pieces. Now, this machine right here, actually, if we invite schools. In fact, somebody this morning had put a comment, why don't you do a train the trainer? We train educators all the time. We work with educators, and they always ask, well, why can't we get this machine right here? How much does it cost? And I always tell them it's not for sale. When people are like, well, why don't you sell that machine? Because it's not about the machine. It's about putting you into a situation where you feel like you're right at the job site. And so that's what I'm going to try to walk you through today. So I'm actually going to walk you through our expectation exercise that we do with this. Now, a couple things is I didn't comment on many of your posts. I did push a few of you on, hey, how you really thinking through this, but I didn't comment on many of them. But there were some repetitive things that are about the same as, I hear when people come here is, I ask, well, how do you troubleshoot a machine? Well, I go check the HMI and see what it says. Now, here's the pitfall of doing that is most HMIs Honestly, well, even my first HMI, when I said I added diagnostics to it, it had the IO states, told you if the e-stop was pressed, some real basic things. The idea that in 5 years, that linear rail was going to be worn out and was going to drop down and was going to start nicking the sensor and cause an erratic issue just never really occurred to me. So while we do want HMIs, we do want good written programs, that cannot be our only troubleshooting is to walk up to the HMI and figure out what happens. Now, the other interesting one is you're going to find that I'm getting ready to tell you to do the exact opposite of what everyone out there said to do during this. And we'll get to that in a second. But first, yeah. So what do we do if we, because the other one is a lot of you said, well, I would study on the drawings and the program for a while and get real familiar with it. Well, the machine is down. Do you know how much downtime is per minute? In fact, I just did that, and yeah, small business manufacturing downtime. And we're talking companies that are probably just a little larger than, Amber and me. It is $150 to $450 a minute. So while, yes, we want to be as familiar with a machine as possible, we can't really tell someone, well, okay, let me come back tomorrow after I've had time to review. We've got to have some strategy about how we can go through an unfamiliar machine, which kind of brings us to this machine. This is the unfamiliar machine. And yeah, we don't do a lot of videos on this one because if I do videos on it, then it becomes the familiar machine because, before you come to my class, most of you have watched a bunch of my videos. But I am going to give you a peek inside the program and kind of how we work through it. But this machine here on Wednesday, you have to fully reverse engineer because we need documents, we need drawings, we need a program with descriptions. Well, there are no drawings for this, there are no program descriptions, and there is no user manual. So literally they have to walk up and figure out even how to start this thing. And I'm going to give you a little peek into it because it doesn't take that much to figure out how to do it. We hit the green button. Motor turns on, little valve opens up, little thing turns there. And yeah, we're just blowing a ping pong ball up, but we're actually doing PID equations, all types of stuff. So there's a lot of troubleshooting abilities in this machine. But how do we troubleshoot it if we just get a call? Because a lot of us, we do field work, and we get a call from a customer. They're like, hey, I got a machine down here. Can you come help me? Well, okay. That's probably all the info we get. Which brings us to the really golden rule of troubleshooting is go ask the operator what it's doing. And it's funny, when people come to the class, because, by the time you're in my actual classroom, you've got some experience. You've probably butted your head against the wall. You've butted your head against operators, management, everything else. And, I'm like, well, what's the first thing, you do? Should you talk to the operator? Oh, they've always gone to lunch by the time I get there. Well, go get them off break. Go figure out what the machine is not doing. And you really need to become good friends with the operator because really, if you're good friends with the operator, they'll give you more info. If you seem like the guy that's talking down to them all the time, they're going to give you a lot less info. And this doesn't just go for troubleshooting. This goes for if you're making machine upgrades. I've made upgrades on machines and, I get there and I put them in and the operator's like, this is never going to work. I'm like, well, this is what management told us to do. And you guys put that in, one guy put that in the comment the other week. It's like, well, I get paid no matter what. I'm like, yeah, you get paid no matter what. But, if you are the one that goes and talks to the operator and says, hey, this is what we're planning on doing. And then the operator tells you, no, that won't work. And you go back and say, hey, found out we need to adjust this away. Management's actually going to be much happier with your job. And yeah, you're going to get paid either way. But do you know what happens next time? They're like, hey, call Tim and get him to go talk to such and see how to upgrade this. Hell, we didn't even have to get a quote that time. We were automatically in. So talk to these operators, figure out what's going on. And the other one that I did want to address before we get into how to troubleshoot is a lot of you said, well, it's usually a mechanical problem. And Tony Leroy actually put it best on this one. He said, in my time of maintenance, I found it to be 75% of problems to be mechanical, including hydraulic and pneumatic, 15% to be electrical, and 5% to be program related, and 5% other. And here's the thing, If you walk up and you say, it looks like a mechanical problem, do you think they're really going to call you back? You're going to become that programmer or that technician or whatever you want to call yourself, that they're like, well, if it's a necessary evil, call Tim. But in no other circumstance should we even call him. Now, if you go out there and you troubleshoot, and okay, you're right, it's going to be mechanical. But you know, the HMI actually is going to say motor overloading. Well, who else are they going to call? Hey, Tim, I got a motor overloading. Can you come look at it? Well, yeah, the motor is fine. We know the bearings are locked up, but then you go out there and you find the bearings, point the bearings out, and be like, hey, here's the two bad bearings. I mean, you just saved the mechanical technician so much time. They're going to value you. The manager's going to value again, and yeah, it's going to get to the point they call you. Hey, Tim, go check out what this is. And so it's going to help you build a better relationship. All right, now we're getting ready to get into how to do repeatable troubleshooting. But yeah, let me see. What does the chat say? Because I haven't even brought the chat up. Hey, Christian, very nice to see you. Good, hello from Chile. Kevin Burke, good to see you. Glad you're looking forward to it. Philip McBride, yes, operators invaluable. Absolutely right. See, Bevan, yeah, I agree that operators know the machine, and they do. Now, and that's, so, well, let's just wait, because we're going to go to that in a second. See, Arc Living, HMI is about like a check-in. Well, and here's the thing, you're right, Arc Living, and it's not the necessarily. Now, in a lot of cases, it is the programmer's fault. But I think most programmers at the level they're at have no idea how to truly troubleshoot an unfamiliar machine. And that's the key, because a lot of you did put in, well, you know, I wrote this program and I put all this stuff in. But okay, how would you go troubleshoot someone else's machine? And that's the mindset you really have to put yourself in to write good programs. Because, you know, we always say we help you become a better technician. Our training is for technicians. Now, we do get engineers in here. We actually get manufacturers of equipment in here that have to support PLCs. But they're not good candidates for our class until they realize, you know, we got to support the technicians. I need to learn how to write better programs. At that point, they are a fit for our class. Before that, they're not really a fit. Excuse me. All right, Mark. Are there any instances where the machine is missing a schematic? Almost always. And that's the funny part. You know, when I put this post up, I'm not knocking. Yeah, I am slightly knocking. I can't lie. I am slightly knocking because it is experience levels. There's a lot of you are like, well, we always have diagrams. You have not been beat up enough in the field. There's not a single person that walks into this class. When we go on Wednesday, what is it? Step 3. Can't even remember what step it is. But one of the steps is figure out what's wired to each input and output. And everybody's like, oh, it's just another day at work. Because, yeah, it happens all the time. We don't have wiring diagrams. The diagrams are old. Somebody did a retrofit. They didn't upgrade them. Somebody redlined some wiring diagrams and they got lost, and we had to go pull wiring diagrams that were on file that weren't ever marked up. It's common for us not to have that. See, Levi, let's see. Nearly every machine in our plant is missing prints, usually the micrologics with very few files. Yep. People who say, yeah, you know, I used to try to correct, or not correct, but encourage people, you know, if you're out there saying, well, I'll get paid anyway, nah, you're not gonna ever, until you get past that point. I just wish you could realize how much one greater your career could be if you could get past that point. My mom's here. Hey, Mom. Let's see, Jace. I remember software for troubleshooting. It was odd to simulate issue, but rewarding. Yeah, and you're right. And you know, simulation is very difficult. Yeah, and prints are very helpful. But okay, this is the expectation exercise right here that we do with the technicians. Zoom in a little bit here so we can get close on it. And I always start this off asking the technicians, did your boss send you here to learn how to guess? And of course, they all shake their head no. Now, out in the field next week, I told them, I want you to use the best guess possible. But this week, we want to think through the problem. And really, that's all they don't realize. This is a whole, and I know I'm dating myself by talking about The Karate Kid, still one of the best movies ever. But the whole wax on, wax off philosophy, that's all we're doing here. Is we're really teaching them how to think through problems. And when all of a sudden on Thursday, and we're flipping switches on this, which I didn't mention, yeah, there are 40 switches on the side of this. There's actually ultimately about 130, 140 combination situation of breakdowns that we can simulate with it. But when we start flipping these switches, all of a sudden they realize, oh man, I can troubleshoot. I didn't, half of them come in on Monday. I've never seen the inside of a PLC program. Teaching PLC program is easy. If somebody is really wanting to learn how to troubleshoot, I can walk them through that. But again, this is the expectation exercise. So I always ask, did you learn here how to press a button? Does anybody need to learn how to guess and press a button? Do you need to learn, how to do, any guesswork? And they're always like, no. So I said, okay, I'm going to press the E stop. And when we walk up the machine, what are we going to do? And inevitably, about 50% of the time, one of the guys like, well, I always check the E-stop when I first get to a machine. I'm like, your boss did not send you here to learn how to twist an E-stop, though. And so the first thing is, well, what does the operator tell you is happening? And so I'm going to hit my buttons. And of course, it doesn't work. Now, here is the key to troubleshooting that honestly, only 2 people, besides my 2 technicians who've already been here, yes, I give you kudos, I am proud of you. Only 2 of you really nailed down is what is the next step when it's not working? And here's what I tell them during this expectation exercise. Find the action item that it's not doing and start with it. Now, it's funny how really at this moment during the expectation exercise, it always still goes the way that every one of you is thinking out there. I ask them, well, what should we go check? And they'll be like, well, I think we probably need to check the green buttons. I'm like, do they do action? And they're always like, well, yeah, they start the machine. I'm like, no, they do not start the machine. The PLC reads the buttons. Those are inputs. If it was an action item, the PLC would be magically making those buttons move. So what is that action item? Now, there's 3 action items. We've got our intake damper, we got our butterfly, and there's a fan right here. Now, here's the trick to doing it this way compared to guessing at the buttons. Even if you choose the wrong one, it'll lead you to the right one. Because I'm not gonna use anybody's post on this because I was really appreciative of how open everybody was about it. But one person said, and I'm paraphrasing, well, I would check this button and make sure it's working. And then I would have to go check this one and then I have to check this one. It's pretty much a wild goose chase at that point, but usually I can work my way through it. And yeah, for a lot of us, that is how we're doing it. And even on a machine this small, because I counted it up this morning, if you go off of inputs, there's 46 possibilities that could be preventing this machine from starting. And the issue is, if we check the green button and it works, then have we learned anything about the other 5 conditions, 45 conditions? Have we narrowed anything down, or did we just figure out one and we're back at square one? Yeah, we're back at square one. Now, if we start at the action item, let's just pick this valve. Can you see the valve? Yes. So this red valve right here needs to open up. If we pick that valve, then we know for sure that valve's not working. If we go and we find that valve, we're going to be able to work our way back and figure out why it's not working. Now, here's where there's 3 sayings that people say, I say all the time in this class. And yeah, in fact, let me go ahead and switch over to my screen. Gosh, guys, I have my screens all in the wrong places because we're over here now. Screen, there we go. And so, yeah, this is the program right here. And immediately everybody wants to go and they want to open up a main routine. And I always ask them, why are you doing that? And they're always like, well, that's where I always start out at. And yeah, here goes to my famous 2 sayings that everybody says I have to have a shirt for is, take your hand off the mouse, quit scrolling. Because if we open up that program the way we just did, that's our only option, is to scroll and only use our eyes to find the problem. Now, if we want to know what a value is in the PLC, and this is a foreign concept still for a lot of you watching this video at this moment, that output is a value. It is a 0 or a 1. It is not on or off. On or off are some other type of terms. Those are not in PLCs. We're looking for a 1 or a 0. If we're looking for a 1 or a 0, a 1, 2, 3, 4, 5, or any value, a string, a word, dog, cat, kangaroo, giraffe, whatever, we want to start in the controller tags. You want to start in fact, I have never found a situation, and again, we're talking about repeatability. Oh, well, I always just go to the input because it's always this one. I get that you can guess. But if we always follow these steps, we will repeatedly get the result. And then if we practice these steps, we can gain the speed. And so, yeah, we're going to go to our controller tags. If I can find my mouse, I'm going to get there, guys. Where's my mouse? Anybody see it on the screen? Oh, man, really got to get my screen. There we go. We're going to open the controller tags. And then you're going to take your hand off the mouse. And that's it. You see already, because even here I'm getting worked up about it, because the next thing everybody wants to do right away is they want to start scrolling. Well, again, you're at the mercy of your eyes now to find this tag. Now, here's where it gets difficult on my programmers and people converting from the software market, because you guys lecture me all the time, because I make sure I sound it out with all of you what the tag is. And sure enough, somebody always says, well, if you make aliases, you could find that a lot easier. Here's the issue with relying on aliases. Now, I love aliases. Aliases are great for a lot of things. If you don't know what an alias is, it's a way that we can name a tag without having to know the funky tag name that actually gets us to the wire. Now, here's a trick, and why you can't do that when you're troubleshooting is when they reverse engineer this, which the reverse engineering is the same as if we walked up to it. What are they going to call this red thing? Whoops, didn't do the zoom screen. What are they going to call this red thing? It's really interesting. This is, depending on the group, it can be called the butterfly valve. It can be called the red rotary valve. It's been called the intake damper. It's been called the exhaust damper, because nobody knows yet which way this actually operates, but it gets called all different things. So nobody is going to be able to take your alias that you're sure is perfectly named and find it. Right now, all we know is this thing is wired to the PLC. And I can't tell you that, and this is, technicians, this clicks fairly quick with them. This is where all of a sudden you can see the software guys really struggle a little bit. I'm not picking on the software guys, because actually we convert a lot of people in software engineering to our industry. They see the light and they realize, oh, if I learned this hardware stuff, I could actually do this. Really cool. But what does the tag name start with if it's touching the PLC? That is the one question that you guys struggle with. It's going to start with local. And we have videos about the address and really specifically, so I'm just going to talk about the compact logics. In the case of the L18, the base is going to be local :1. And then, am I trying to tell that valve to open, or am I trying to read its position? We're trying to tell it to open, so it's going to be an O. So before we even think about scrolling, we should be going up to our filter here and type local :O. Whoops. And right there, local :O, data. And yes, this is the unfamiliar machine, so I have removed most of the documentation, but I did leave the butterfly valve in so that we could see it. Now, here is the interesting part for the ones that just love to scroll. And this is why everybody says I need a shirt to, tell you to quit scrolling. Because I will watch them at this point on Thursday, and almost always their mouse starts heading over here back to the main routine. And I'll tell them, take your hand off the mouse. And I'm like, what are you trying to do? And again, they'll be like, well, I need to get the program open so I can go find it. Well, no. That's why we have my third rule, because yeah, we take our hand off the mouse, we quit scrolling, and then we right click and we're going to get options. And this is going to give you, Studio 5000 does an outstanding job of giving you options for exactly where you are. And if you want to know where something is used in a program, then we're going to go to the cross-reference. And this leads us to the next one that most of you would probably agree with, is most of you are going to be looking at these XICs and XIOs right now. And it's the most common thing I get when you guys email me asking me, hey, can I come to your class and try to learn how to troubleshoot better? Is you're like, I don't know which XIO and XIC to go to. It's always a struggle. Well, the answer is neither. Because right now we want to know what is controlling the motor. And for that, we have this destructive column over here. And I really wish this was called read write and we just had R's and W's. That would be a lot easier, I feel. But destructive means, can this instruction write to this tag value? And so we're going to double click on the destructive column. That's going to sort it one way, but double click on it again if we had a bunch of them. That's going to put all of our Y's together. And also, but do not put in my comments, go ahead and take your hand off the keyboard because I know some of you are getting ready to do it. Oh, you got a duplicate output. You can't do that. We had this PLC riddle several riddles ago. You can have duplicate outputs on large programs. You will have duplicate outputs. So in this case, we're going to go to the first one. We're not going to think really hard. And yes, there it is. And just to make your life easy, I did label input 9. So now we would know local :1:0.data.9. We need to go troubleshoot it. Now, let's go ahead and walk through it one more step. Because, okay, let's say this was really complicated. I made sure to pick a rung that was fairly simple. When you get in the weeds, here's where my instruction style works better than most people's, or what you're taught, and yeah, what a lot of you come to me telling me is, in fact, yeah, I wish I should, I should have used this for a PLC. Well, yeah, I can't use it for a PLC riddle if I tell you, but I got a new PLC riddle, just came up with it. But a lot of you are going to tell me that this is a normally open instruction, or you're going to tell me it's an examine on, or if you're from some of the older logic, it'll be an examine if closed. This isn't. This is a go look for a 1. And the reason is because it's going to be looking for a 1, and in this case, it actually is an alias called SS. And if we mouse over it, it has a value of 1 in it. So it looks for a 1, it has a 1, so it is true. Do not always trust the green on the screen. When insanity starts kicking in or your mind is spinning, start mousing over these and doing your truths. So then we can mouse over this one. This one is looking for a 1. We mouse over it, it has a 0, so it is false. So this is one issue. And then this one is looking for a 0, and it has a 0, so it is true. This one looks for a 0, it has a 0, so it's false. And this one looks for a 1, it has a 0, so it is false. So we have 2 conditions, and yes, we know that this one's it. But I want to go ahead and talk to you. I'm going to take you a little further through the run. That way we can just kind of understand how to narrow this down. So we're going to right-click it, and we're going to go to the cross-reference. And I can't tell you, here's one of those other times where I tell you to take your hand off the mouse, is people get here and they see this, and immediately they want to go back to the main routine where they were and start wandering around. And here they go. They're going to start scrolling, and they're screwed at that moment. Take your hand off the mouse. Quit scrolling. I'm not telling you this to be bossy. I'm telling you this because, yeah, anytime you do that, you're gonna get lost. We know this is probably the culprit. It took us to this cross-reference, and we really didn't like it. And here's the thing is, we may not like it, but it definitely is the culprit of our issue. So we've got to be able to just focus in and take them one at a time and eliminate all of them. And there's going to be one that's left that is the problem. And so, yeah, we're going to go back. And again, we're looking for something that writes. And, where'd my mouse go? So we're at the destructive column. And we can take that a step further, though, because now we're looking for something that writes a what. And now we can move over here and we can look, we needed a 1. Well, you don't know what this is if you haven't been into structured text much, but I bet you can take a wild guess what an equals 0 is. This is going to go right as 0. We have an OTL, and if you've watched any of my videos, that is not a latch instruction. Latches and unlatches do not exist in PLCs. This instruction, when it is true, will go right a 1. And when it's false, it does nothing. This is an output unlatched. It goes and writes a 0 when it's true. It does nothing when it's false. And same with that one, that one, that one, that one, that one, and that one. So before we even went anywhere, before we freaked out and went back here, we've taken all of this and we brought it down to this is the only place we actually have to look. So that's just a little bit on how we kind of teach troubleshooting in this class. And like I said, this is not the fastest way to troubleshoot. But this is the most repeatable way. And as you get into more complicated problems, it is the only way. And that is what's going to get you to that next level, whether it be the next pay level or get you into the big custom that you're looking for. That's really the big thing. Let's see. Let me check. Where are we at on this? Let's see. I did arc living about the about the check engine code. Yeah, many instances are missing machine schematics. Let's see. Yeah. Oh, where is my? Oh, hi, Michael. Good to see you. Let's see, Mark. If the machine is truly unfamiliar, I would recommend looking on the label of the enclosure with the contact info of the company that designed the panel. You might be able to get a copy of the logic prints, and you're absolutely right. And here's where we've got to swallow our pride. I don't care if it is your most fierce competitor that you really do not like. Go ahead and call them. One, y'all may find out you can at least go to lunch, catch up a little bit, talk about some things. But yeah, we're a small industry, and if a competitor called me and needed a drawing, I would send it to them right away. Now, in this case, this is set up. In fact, I didn't bring a book with me. The narrative is this is a machine. The company was out of business, and there was no proper documentation done. And so, yeah, you're having to work your way all the way through it. See, Eric Fowler, I always try to find out how was the machine working properly. And this is interesting. Here's why, you've got to really put faith in your operators. And I do see management not doing this enough. As I walked up one day, it's a machine that, I've worked on many times. The manager comes up and they're like, so Tim, how do you think we could adjust blah, blah, blah? And I'm like, I don't really know how this machine runs. And they're like, we always call you when we need work on it. I'm like, yeah, but it's always broke. I'm like, go talk to the guy who runs the thing. I have no idea how this thing's supposed to run. It's not to fix it. So yeah, the operators are incredibly important to you. Dan Stafford, I did have two people say make sure you back up the program before you start fixing it. Not modifying it. And I was like, why do you need to modify the program? And actually, I'm going to pick on my dad. He's passed about a decade ago, but mechanical genius, and I never could figure it out. If he had a problem, he'd start adjusting the program. I'm like, the machine was running last week. What are you doing? Well, something's wrong with it. Nobody changed the program. So don't get me wrong, we do need a backup of a program, but we don't need to actually modify, which brings up another point, because I do have a lot of, I won't say it's usually, because actually the head maintenance technician is usually not the one. It's usually someone further in management will say, we don't really want our technicians, editing the code. Do you have any alternatives that, wouldn't have that part? And I'm like, well, what do you mean? You want them to be able to operate a voltmeter, talk on a cell phone to the programmer? What are you looking for? And here's the thing, if you're worried about a technician messing the code up, your absolute best idea is to get them as fluent as possible in the PLC programming and in the code. Because then they're going to understand it enough that it's not going to be this magical thing. Two things that I really will light a fire under me, especially if you do it by Friday, is toggling bits and forcing. There is no need to do either of those in a program. But when people aren't really familiar with it, that's the first thing I want to do. If I could just toggle this bit, I know this machine would run. Okay, why is the bit not on though? And they're always like, well, I don't know. I'm like, well, that's what you got to go find. But if we have them fluent enough in the ladder logic, then they're going to be like, oh yeah, I just need to go figure out why that thing's not on. Let's see. They use the cross reference to find the destructive bit all the time. Yeah, and honestly, there is, we talk a little bit more in detail about it when you come to our training. There are times to look at the nose, and it actually is dependent on what you cross reference. So if we just go back to where we were, oh gosh, yeah. If y'all saw where my screens are at here, because this is obviously is not the normal spot, so my screens I kind of just got them over here enough for this live stream. But if we go back through this again, we know here we needed a 1 in this box to make that valve open. And that's why when we right-clicked and we cross-referenced here, we went to the Y column to figure it out. Oops, I went to the wrong Y column. Okay, I accidentally did this. We might as well go through it. People talk all the time, oh, you can't have duplicate destructive bits. Well, yeah, you can often. It's called simulation code. And here's why I tell you to pay attention to these green bars. Because there's your only little bit of indicator that this rung is not being ran. But obviously, here's the other insanity indicator is that, yeah, those aren't matching up. But if we go back there and we go to this one, everybody can get to that. But yeah, when you go to cross-reference this one, we are looking for a Y. Now, what I always tell people is we're always looking to do the opposite of the instruction that we went to. So this right here goes and looks for a 1. So it is a no in the destructive column. So if you cross-reference a no, if you're cross-referencing an instruction that can't write, you're looking for the opposite. And that's how we ended up on the Y's there. But anyway, destructive. I've never, yeah, Levi, I wish it was called something else. So yeah, you may have missed the beginning of it there. This column right here is whether something can write to it. And I really wish this was called the read-write column. And then these would all be W's because they could write. And these would all be R's because they couldn't, because they could only read. But yeah, so this column right here is the key to troubleshooting, really, is this one right here. Because really, I don't know how many's here, but there's 20 some things. And especially if most of you, with what you said, you're going to go start and look at these XICs and XIOs trying to find out what's wrong. And you almost never need to look at them. In this case, we only needed to look at this one right here and we would have found the problem. What else we got? Because really, there's kind of a little bit about troubleshooting, and I would love to do some troubleshooting videos. Also, I would love to build some troubleshooting trainers, but we built one troubleshooting trainer, and actually I still have the prototype over behind my junk pile. Nobody was interested in it. I think everybody kind of want, I don't know, you either need this or you need to just sit there and practice. That's really the two ways. Anyway, that's all I have for today. If you'd like to learn more about my classes, then there's probably going to be a link up here later on talking about it. And yeah, here's a playlist. I'll put a little later over here that has some other helpful troubleshooting